Chapter 1, General Principles. Okay, everyone. Today, we are going to talk about the basic rules that help engineers design things like big cranes, cars, or even rockets. Imagine when you are playing with toy blocks. You need to make sure the blocks don't fall, right? You have to think about balance and how to stack them properly. That's exactly what engineers do, but with much bigger things. We call these basic ideas mechanics. Mechanics is like the science of how things stay still or how they move when forces push or pull them. We break mechanics into three big parts: solid things that don't bend, called rigid body mechanics; things that can change shape, called deformable body mechanics; and liquids like water or air, called fluid mechanics. For now, we will only talk about rigid things because that's the easiest to start with. In rigid body mechanics, we have two ways to study things. First is statics, which is all about things staying still or moving smoothly like an elevator going up at the same speed. The second is dynamics, which is about things changing speed, like a car that starts moving faster or a ball that suddenly stops. It's like how you can be standing still or running on the playground. A long time ago, smart people like Archimedes talked about simple machines, like levers. That's like when you use a seesaw. Later, people like Galileo and Newton came along. Galileo watched balls rolling and dropping, and Newton gave us three famous rules called Newton's laws. They tell us how things move and why they stay still or speed up. These laws are super important for everything in mechanics. Now, to understand how things work, we need to know four simple things: length, time, mass, and force. Length tells us how long something is, like measuring your height. Time helps us know how long something takes, like waiting for cookies to bake. Mass is how much stuff is in something, like comparing a small watermelon to a big one. Force is like a push or pull. For example, when you pull a door open or push your friend on a swing. To make studying easier, we use some tricks called idealizations. First, we sometimes treat objects like tiny dots called particles. For example, when we talk about Earth going around the sun, we imagine Earth is just a small dot. Second, we imagine things are rigid, which means they don't bend, just like how we think of a steel ball staying round even if we push it. Third, we think about concentrated forces, meaning all the push or pull happens at one spot, like pressing your finger on a table. Newton's laws are like playground rules. The first law says if you don't push or pull something, it will just stay still or keep moving in the same way. The second law says if you push harder, things move faster, like when you kick a ball harder. The third law says if you push on something, it pushes back equally, like when you jump off a boat and the boat moves backward. There's also gravity, the invisible pull from Earth that makes things fall. Newton explained it with a special formula. Weight is just the force of gravity pulling on your mass. That's why on the moon you weigh less, but your mass stays the same. In America, they sometimes use feet, pounds, and slugs, but engineers mostly use SI units to make things easier to understand around the world. Sometimes numbers are really big or really small, like when we talk about how far planets are, we use kilometers or megameters to make the numbers simpler. When things are tiny, like bacteria, we use millimeters or micrometers. Engineers use special words like kilo, mega, milli, and micro to make counting easier, like saying 1,000 grams is 1 kilogram. When we solve problems, we have to be careful with numbers. We only keep numbers that are important, called significant figures. It's like when your mom says you have 3 cookies, you don't need to count the crumbs. We also need to make sure when we add or multiply things, they match in units. It would be silly to add apples to meters, right? And just like following steps to make a cake, solving engineering problems also needs steps. First, you read the question carefully, then you write down what you know, draw pictures, use the right formulas, do the math, and finally, check if your answer makes sense. For example, if you calculate your own weight and it says 1,000 kilograms, you should know something is wrong. So, in summary, mechanics is all about understanding how things move or stay still using simple ideas like force and mass. We follow Newton's laws, use correct units, and follow step-by-step methods to get the right answers. And always remember, being neat and thinking clearly makes you a better engineer, just like it helps you build taller towers with your toy blocks.